Write a formula for a recursive sequence. Majority of the time, you're going to have to be able to choose a recursive sequence. And whenever you're doing choosing recursive sequences, you're able to test these because you're given the numbers. The thing you got to remember is whatever place the number is in is your x value. So if it's the third number in the list, it's going to be 3 for your x value, and then your output's going to be whatever that number was in the list. So you can see how we kind of set this up and start narrowing it down. Well, I mean, we're trying to find a pattern, right? We're just trying to find it out. And once we have an idea of a pattern, then we can start substituting and checking our work. So which recursive formula can be used to define the sequence for n is greater than 1? We have to have n being greater than 1, which is why you're usually given the first term. If you're given the first term, then you're able to find the second term, because we know with recursive sequences, you have to have a term to find the next term. That's part of the recursive. It's dependent. The next one is dependent upon what the previous one was. So you can take a look at some of these right here. You can see that we have the term in this first one plus the term minus 10. So term plus term minus 10. Or we have whatever the term was, add 10. We have whatever the term is, multiply by 10. We have whatever the term is, multiply by 11. What I like to do immediately is just go ahead and number these by their places. So 42 is the sixth number, negative 8 is the first number. I'm going to go ahead and set up an XY table because it helps me look at this stuff. So 1, 2, 3, 4. And I don't have to do all the numbers. We're just going to have to check 2 or 3 of them. Then negative 8, 2, 12, and 22. Now that we've got this set up, we can say, all right, well, what exactly is happening here? Well, we can see that this is going plus 10. Okay, so I'm identifying a pattern. And you can do that over here too. You can go, okay, so plus 10. I can see that it's growing by 10 for each term that it's going by. So we know that it's not going to be something that's taking away 10. So I'm going to go ahead and just assume it's not that one, because what we're trying to do is eliminate something. So I know it has nothing to do with 11 either, because I'm seeing that it's growing by 10. So I'm leaving the only two that are growing by 10, plus 10 and a factor of 10. Now what we can do is we can just kind of take this second one. I'm going to put a star next to it. And we can take any of the terms and plug it in. So let's go ahead and take a look at this second recursive formula right here and substitute some of these values in and see if it actually outputs what numbers we're given. So let's say we're looking for the second term. So we're looking for 2. It is going to be a2 minus 1 plus 10. So when we're evaluating, we know that's going to be the first term plus 10. The first term was negative 8. So I'm going to substitute that in for the first term. Then I'm going to add 10. So that means we know that A2 equals positive 2. Good. That checked out. All right, so far this is good. I always like to check 2 of them. If I check 2 of them, I feel pretty good. So let's use this next one for the next term, right? So let's try and find the third term. That's going to be A3 minus 1 plus 10. So A3 we're going to evaluate. So we're going to use the second term and add 10 to it. The second term was 2. So that's going to be 2 plus 10. So that means the third term in the list should be 12. And it is. Nice. So that's a way that we can go through and check. All right, we're kind of looking for a pattern here. Which one of these looks like it follows that pattern? If you don't even want to look for a pattern, you can substitute and work all these problems out and you'll find it. So let's go ahead and take that approach for the next one. Like, let's just not even look for a pattern, and let's just use the choices given to us and find out which one we can use. I'm going to go ahead and number these. So the cool part about algebra is we can always substitute and check. There's no reason why we should move on from a problem not knowing if it's right or wrong. So if we wanted to know the second term, hey, second term's 2 again. Then what I'm going to do is I'm just going to, looks like it's multiplying by 2. So I'm just going to save myself a little bit of time. So here and here. This only one looks like it's multiplying by 2. I know it's not going to be the plus 2 because it's going from 4 to 8. That wouldn't do that. And then 8 to 16. So times 2 times 2 times 2 times 2. So I'm going to go ahead and start with this one right here. You can see how that process of elimination in itself just saves you a moment. So let's go with the second term, 2 times the second term minus 1. Evaluate, so 2a1. So we know that the first term was 1. That's going to be 2 times 1. So our second term is 2. Check. Let's use that information to see if it works for the third term, because we know that recursive sequences, if we use one term, we have to use that term to find the next one. 2a3 minus 1, evaluate. Okay, so that means now we're using the second term and be multiplying it by 2. The second term was 2, and we just found that right here. Okay, so we know that the third term is going to be 4, and the third term was 4. This is good. These are just some approaches that you can take to writing and reading recursive formulas when given a list of numbers.